Hey sixth graders, Mr. Ronin here. I have another video for you guys. This one I'll just call Finding Surface Area. This video will cover what surface area is and how to find it, and it'll also include a little review about how to find the area of parallelograms as well as triangles. Alright. Alright, so before we get started with finding surface area, we're going to key in on how to find the area of parallelograms and triangles. In this shape right here, you guys will probably identify it as a rectangle, and that's true, it is a rectangle, but for our purposes today we're going to go ahead and call this a parallelogram because we noticed that there are four sides. We have one side here, another side here, another side here. It's a prerequisite for parallelograms to have four sides. So right off the bat we see that this has four sides. What we also notice is that the opposite sides, or the sides directly across from each other, are parallel, meaning if they were to extend and keep on going, they would never cross each other. They would never touch. We see that's the case with both sets of opposite sides. So having said that, we know that this is a parallelogram. So, and we know how to find the area of a parallelogram. The formula to do that is area equals base times height. Sorry if the handwriting's a little shaky. I am doing this on an iPad and typing with my, writing this out with my finger, so it's pretty tough, pretty difficult. But anyways, so we know that in order to find the area of a parallelogram, or a shape like this, we need to multiply our base by our height. And I'm going to go ahead and say that 4 is our base because it's going straight across. That's not always the case. We can say if we wanted, we can move this. You see 10 is now going, we could say 10 is going straight across now. So we could say 10 is our base, we could say 4 is our base. Doesn't necessarily matter. So I'm going to try and line this back up here. Try getting a little fancy there. Alright, so I'm going to continue our formula, and I'm going to write A, which stands for area, equals base, and I want to replace B. I want to get that letter out of here because I can't solve an equation with multiple letters. So I'm going to replace B with 4 because our base is 4. And I also want to get rid of that H. I want to get rid of this symbol right here. In order to do that, I have to identify what number or what value does H stand for. And I need to find my height in order to do that. And the measurement, or the line rather, that goes straight up and down from the 4 is called 10 centimeters. So I'm going to replace H with 10. When I multiply those together, I get 40. But let's not forget, since we're finding area, we have to do centimeters squared. Let's be sure not to forget our units there. Alright, so now we're going to move on to something a little bit more complicated than the parallelograms, and this would be the triangle. As you can see right up here, we have a triangle with multiple measurements given to us. And that's going to make it a little more difficult to find the area of this shape. So let's go ahead and write the formula to find the area of a triangle, where we have area equals base times height, just like the parallelogram. Only this time we're going to divide that by 2. And this is because two identical triangles put together will form a parallelogram. If you need a reminder on that, there's a video called Finding the Area of Triangles on my channel. Go ahead and click that if you need a quick reminder, a quick review on that. But for time's sake, we're just going to keep this rolling. So we already have few problems here because I know that I'm going to be multiplying two numbers together, but I have 4 to choose from. 4 different numbers to choose from. So how do I know which ones to choose from? What I always like to do is I would like to find that right angle. I always like to find that right angle first, and I have it highlighted right there. And what that right angle is going to do is it's going to tell us what two numbers to multiply. So for example, if there's a line that makes contact with that right angle, we're going to use that in our equation. So if we notice this line called 4, it does make contact with that right angle. If we look at the side called 12, if we were to keep going, it makes contact with that right angle, whereas 5 never touches that right angle, 9 never touches that right angle. So because of that, I know what two numbers I'm going to multiply. I'm going to multiply 12 and 4. And again, with multiplication, it doesn't matter which number we multiply. We could do 12 times 4 or 4 times 12. We'll still in the end get the same answer. So I'm just going to go ahead and say 12 times 4 divided by 2. When we multiply 12 times 4, we'll get 48. If we divide 48 by 2, we're going to end up with 24 units squared, right? Because we're not told whether it's centimeters or inches, we're just going to go ahead and be safe, and we're going to just write units squared. Again, if this was too fast, just the idea of this was just to be a quick little review. If you need a little more of a review, go ahead and view my channel, or view a video called Finding the Area of a Triangle on my channel. That should be helpful. Okay, so now we're going to move on to surface area and how to find that. We usually find surface area when we're dealing with three-dimensional shapes or 3D shapes. As you can see with this is a 3D shape. Okay, it's not two-dimensional like those triangles and parallelograms we were looking at. However, it is made up of two-dimensional shapes. As we can see, if you follow the cursor, right here we have a rectangle. Right up here, we have, it looks like a square or a rectangle. Over here, another rectangle. So again, this rectangular prism that we have right here in front of us is made up of 6 different parallelograms. So if you want to count those different parallelograms, we'll go ahead and say that it's made up of 6 different faces. Okay, 6 different shapes come together to form this rectangular prism. And in order to find the surface area of this rectangular prism, what we need to do is find the area of each individual face. So again, we have 6 individual faces in the shape. That means we're going to have to find the area of 6 different parallelograms and then add all of those up together to eventually find out what our surface area is. So it's really important to take our time with these, okay? We really need to be patient when we're solving these. So the first face that I'm going to work with, I'm just going to find this face right here in the front. And it looks like the base is 4, if you follow my cursor. And how tall is it? Well, we're not given a measurement for this side, but if I look over here, I'm told that this is 6 centimeters. 6 centimeters. Since this is 6 centimeters, I know that this side right over here, the side of this face, is also 6 centimeters. So we know that this face that we're dealing with right over there is a parallelogram or a rectangle. So I'm going to go ahead and write down my formula to find the area of a parallelogram. Area equals base times height. What I notice here is, like I said before, our base is 4 and the height is what goes straight up from it. So I'm going to go ahead in our formula and I'm going to replace B with 4 and I'm going to replace H with 6 because that's what the height is. And when I multiply those together, I get 24. So I see that this face right here has an area of 24 centimeters squared. I'm going to make sure I remember that there. 24 centimeters squared. Now I could go ahead and continue and find the area of this face right here, and the area of the face in the back right over there, and the area of this face right here. Or I could save myself a bunch of time and recognize that each of those 3 faces that I just point out all have a base of 4 and they all have a height of 6. And that's exactly what I solved with this right here, 4 times 6. So I'm going to go ahead and do is I'm going to do 24 times 4 because I know 4 faces are going to have an area of 24 centimeters squared. And once I multiply 24 by 4, I'll end up getting 96 centimeters squared. But remember, that's only 4 of the faces of this rectangular prism. I have 2 faces that I still have not touched. The face right up here and the face right down here. And just off the eye test, I can tell this and this are going to be identical. They both have a base of 4. They both have a height or length of, or width of 4 as well. So in order to find the area of that parallelogram, I'm going to use a different color here. It's still going to be A equals base times height because we're dealing with parallelograms. And I noticed that the base of this shape is 4 and the width or the height is also 4. So I'm going to do 4 times 4. And that will give me 16. Now I could go ahead and do the math again for this one up here, but like I said, this is going to have a base of 4 and it's also going to have a width or length of 4 as well. So I'm going to save myself the time in math, and since there are two squares with the same area, I'm going to multiply 16 by 2 and I'll get 32 centimeters squared. So now I have the area of all the 6 faces. These 4 rectangles along the sides and then the squares on the top and the bottom. And what I need to do now is I need to add both of those areas together. So I'm going to add 96 plus 32. I'm going to go ahead, I'm going to find my eraser here, make some room. It's not letting me do it. Alright, anyways, we'll move on. So 96 plus 32, and that's going to give me 128 centimeters squared. So the surface area of this rectangular prism is 128 centimeters squared. Now it's important that we really take our time with this. Okay, I kind of went through this pretty quickly when I multiplied the area of this face by 4. That's because I automatically knew that all 4 of those sides had the same area. I would suggest finding one area at a time, one face at a time, in order to make sure we avoid any confusion or silly mistakes that might come from working too quickly. So let's just take our time with these. And the next figure we have is a rectangular pyramid. And I notice that this is a pyramid because, first of all, it only has one base. Remember, prisms rather have 2 bases, and the 2 bases are always parallel from one another. They'll never touch, they'll never cross if they were to extend. Whereas right over here we notice above our base is a vertex. Okay, remember pyramids will have one base, and above that base will be a vertex. I also know that this is a rectangular pyramid or a square pyramid because if I look at the base, I see that that's a square. So remember, prisms and pyramids, they take their name after their base. So if their base is a square, it'll be a square pyramid. If it's a triangle, it'll be a triangular pyramid. So anyways, moving on from this. Here is a net, or a 2-dimensional representation of what that rectangular pyramid would look like if it were to be laid out flat. And it's also, this net also gives us measurements, which will be useful when we're trying to find the surface area of this shape. So let's remember that when we find surface area, we're finding the area of each individual face of a 3D shape, in this case of this rectangular pyramid. And there are no measurements on this pyramid, but in this net, I'm given the measurements. So I'm going to refer to this net as I try to find the surface area of this shape. Having said that, as I look at this rectangular pyramid, I notice that there are 5 different faces, and there's further proof as I look at this net as I see 1, 2, 3, 4, 5 different parts to this shape, or 5 different faces. So what I'm going to go ahead and do is I'm going to find the area of each individual part or each individual shape, and then I'm going to go ahead and add all of those up together at the end. So the first thing I'm going to do is I'm going to find the area of this center piece right here. And I notice right off the bat that the base of this shape is 6 centimeters and the height is also 6 centimeters. So as we know, this is a square. So we already know how to find the area of a parallelogram. Again, we've done this multiple times just in this video alone. To find the area of the parallelogram, we're going to multiply base times the height. And that's going to give us, remember we said our base is 6, the height is also 6. That'll give us 36 centimeters squared. 36 centimeters squared. So since I found the area of that centerpiece, I'm going to go ahead and I'm going to cross that off. So I have one part down, one face down right here, 4 more to go. And I can just tell that these triangles, they're all going to be the same measurement. They all have a base of 12, or rather, they all have a base of 6 because they're connected to this square, or each side of this square. And they're all 12 centimeters tall. Their height will be 12 centimeters. So I'm going to go ahead and, let's just pretend we're gonna find the area of this one right here. And I recognize that the area formula to find the area of that triangle is going to be base times height divided by 2. Hope I don't run out of room here. So I'm going to go ahead and replace the symbols, or the letters rather, B and H, with their values, or the numbers that they represent. So B, I want to find out what the base is. And our base, as we can see, is 6 centimeters, right? Because every side of a square has the same measure. If this measurement is 6, this side is also 6. So our base is going to be 6 centimeters. 6 times the height. And we know that since the base is 6, what goes directly up from 6 is called 12 centimeters. So I'm going to replace H with 12. And at the end, I'll end up dividing that by 2. So when I multiply 6 times 12, I'm going to get 72. So that'll be 72. And for time's sake, I'm not going to, or for space sake, I'm not going to write that. But it's 72 divided by 2, and that'll give me 36 centimeters squared. Oh man, had a hard time fitting that there. So if I know one of these triangles is 36 centimeters squared, I know all of them are 36 centimeters squared because they have the same base and they have the same height. So I notice all the triangles have an area of 36 centimeters squared, and our square also, let's not forget, had an area of 36 centimeters squared. So since each part of this shape has an area of 36 centimeters squared, and there are 5 different parts or 5 different faces of this shape, I'm going to go ahead and I'm going to multiply 36 by 5. 36 by 5. And when I end up doing that, I'll get 180 centimeters squared. And that'll be my answer. So, in conclusion, the surface area, as long as we know how to find the area of parallelograms and the area of triangles, we should have no problem finding surface area. As long as we're taking our time and keeping track of our steps, knowing that if a shape has 6 faces, we have to have 6 different measurements to add together. If a shape has 5 faces, we have to find 5 different, the area of 5 different faces and add all of those together. All right, I hope this was helpful.